This video is going to talk about parallel and perpendicular lines and give you some example problems that you'll probably see on some tests. So first, let's talk about the theorems. If I have two lines, if I have line 1 and it's parallel to line 2, then I know that their slopes are equal. They have the exact same slopes. So let's look at an example here. If I know 2 points of a line, let's say that line 1 has 2 points. One of them is 1, 3, that's the coordinate pair of that point, and another point on that line is at 2, 5. Let's graph those. 1 on the x and up 3 on the y would put a point there. 2 on the x and 5 on the y would put a point there. So these are a line. Now I could look at these 2 points and figure out the slope, or we could use our slope equation. It looks like it's up 2 over 1. Let's make sure. Remember, y2 minus y1 over x2 minus x1. So that's 5 minus 3 over 2 minus 1, which gives us 2 over 1. So it looks like it's 2 over 1. Our equation matches that. That must be the slope of line 1. Let's say we have our second line here, and we know that there are points on that line that are located at these coordinates. Let's plot them. 0, negative 5 would be about there. 1, negative 3 would be about there. Let's connect those points. Well, it looks like they have the same slope, up 2 over 1. But let's make absolutely sure here. y2 minus y1 over x2 minus x1. So we're going to do negative 3 minus negative 5. And that's a double negative, so it's going to turn into an addition. And then we got 1 minus 0. So negative 3 minus negative 5, that turns into addition, so we have negative 3 plus 5, that gives us positive 2. 1 minus 0 is 1. So that's our slope of our second line. That's what it looked like, up 2 over 1. That's what our equation says it is. So looking at or comparing these two slopes, we can see that they're equal. These lines must be parallel. We could draw them even bigger just to prove it. Continuing our slope up 2 over 1, up 2 over 1. So we have something like that. Up 2 over 1, up 2 over 1. Connect them all. So yeah, they look parallel. Our slopes say that they have equal slopes. So yeah, that's enough definitely to prove that these are parallel. Remember, converse says that if line 1 is parallel to line 2, then their slopes are equal. Well, the converse would be the opposite. If their slopes are equal, then line 1 must be parallel to line 2. And we just proved both of them. So that's a definite true statement. Let's clear this off and let's talk about something you'll probably see. Well, first let's talk about perpendicular lines. Then we'll just do the next thing all at once. If we have two lines, if line 1 is perpendicular to line 2, then we know that then their slopes are opposite reciprocals of each other. Alright, so let's take that same example. Let's say that line 1 was located at 1, 3, and another point on that line was located at 2, 5. Let's graph it. 1, 3, start off the exact same way we started that last one. 2, 5. Again, let's come up with the slope. 5 minus 3 over 2 minus 1. We know the slope is 2 over 1. So let's continue putting more points using that slope up 2 over 1. could always do it backwards. Instead of going up 2 over 1, we could go down 2 into the left 1. That's the same thing, because from this point to this point, we're still going up 2 over 1, up 2 over 1. So that should be enough for this line, line 1. And I know that line 2, if it's perpendicular, it has to have an opposite reciprocal slope of 2 over 1. So let's think, what's the opposite of positive 2? Well, that's negative 2, but the reciprocal has to be flipped. So opposite reciprocal means that if this is positive, the perpendicular slope has to be negative, and it has to be a reciprocal, which means we have to flip this upside down, and this is our new slope, or the slope of line 2. So let's start off with the same point. Let's say that this point is also on line 2, and we're going to use our new slope. We're going to go down 1 over 2 now. Down 1 over 2. And we can do that backwards by going up 2, left 2, up 1. Left 2, up 1. Make sure those dots are all on line. And by graphing it, we can see that these look perpendicular. This is line 2. And comparing their two slopes, they're opposite reciprocals. So if their slopes are opposite reciprocals, then they must be perpendicular. And if they're perpendicular, then their slopes must be opposite reciprocals. So we can prove it that way. Alright, let's get to the tricky stuff now. You will definitely see this next problem on a test. It's definitely on your final. You'll probably see it before then, at least a few times. The question is, you need to write an equation. Write an equation of a line that passes through or goes through a certain point, and this certain point is located at 3, 2. Let's find that point. 3, 2 is right there. So our line is going to pass through it either this way or this way. We don't know quite yet. We need to write an equation of a line that passes through that point and is parallel to, they're going to give you this equation, or an equation that's similar, negative 3x plus 2. Well, let's see what that line looks like. Plus 2 for the y-intercept. So I go to the y-axis, put a dot on positive 2, and then I use my slope, negative 3 over 1, to find other points on that line. So down 3 over 1. Down 3 over 1. We could go in the reverse, up 3 over 1. Try to connect these points. And that's the line that we're given. And we want to write an equation of a line that passes through this point and is parallel to this line. So it should look something like this. Let's see if we can get an equation that will make sure we do a line that does exactly that. So if you remember what slopes of parallel lines have to be, they have to be equal. So we know that the slope for the line that I'm looking for, or the equation of the line that I'm looking for, has to be negative 3. It has to be the same. But we don't know a few things in this new equation quite yet. We don't know the y-intercept. We don't know where it's going to intersect the y-axis. Somewhere over here, maybe 9, 10, maybe 11. We don't know. But we do know what x and y are. Those are just coordinates, and we're given those. We know that these coordinates have to be on the line, so let's use them in our equation. And that will allow us to solve for b. So y is 2. X is 3, so we'll do negative 3 times 3, and we don't know b yet. Well, let's solve for b. Let's simplify this. Negative 3 times 3 is a negative 9, and in order to get b by itself, we need to get rid of the negative 9, so let's add 9 to both sides. So 2 plus 9 is 11. 11 equals b. So let's write our equation here. Equation of this line should be y equals negative 3x, it has the same slope, but it's going to pass through the y-intercept or intersect the y-intercept at positive 11. So if we could put that up there, there's 11. We know that's going to be on the line. And we use the same exact slope, down 3, 1, 2, 3 over 1, down 1, 2, 3 over 1, down 3 over 1. Well, there we're passing through that point that we were told we had to pass through. And down 3 over 1. And these two lines look parallel. And we made sure that their equations gave us lines that were parallel. So we wrote an equation of a line that passes through this point, 0.32, and is parallel to this other line. And that's the equation of that line. Let's do one more, similar to that, but now we're going to write an equation for a line that is perpendicular to what we are given. Alright, so same thing. We want to write an equation of a line that passes through the point that they give us, 3, 2. Let's just put that on the graph. We know it needs to be there. And is perpendicular to the same line that they gave us before, negative 3x plus 2. Well, let's graph that one again. Start at 2 and go down 3 over 1, down 3 over 1. And let's do it in reverse here. Over 1, up 3. So we get a nice image of what we're trying to make perpendicular. So it should be something like this. Perpendicular to that should be something like that. Let's see if we can do it. Let's start with what we know. We know that a line that's perpendicular to that has to have an opposite reciprocal slope. So the opposite of negative 3 is positive 3, and its reciprocal is 1 over 3. So the perpendicular slope has to be positive 1/3. We don't know b, we don't know where it's going to pass through. I'm thinking it's going to be 1 or something over there. Well, let's find out. Remember, this is our x, this is our y. We know we're given it, so let's use it. Instead of y, I'm going to say 2. Instead of x, I'm going to say 3. Let's solve for b. Well, 1/3 of 3 is 1/3 times 3 over 1. We would get 3 over 3, which reduces to 1. Or you could just think, well, how many 1's go into 3? Or how many 3's go into 3? Well, 1. And we're still solving for b, right? So get rid of that positive 1 by subtracting 1 from both sides. And now we get that b has to be 1. So let's write our equation. Y equals, we're going to use the perpendicular slope and the y-intercept of positive 1. So let's graph that. So positive 1, and we're going to go up 1 over 3. Well, there's our point. That's what we wanted. We wanted it to go through that point. Well, that was pretty easy to do. Up 1 over 3, up 1 over 3. So our perpendicular line goes through this point, and it's perpendicular to the line they gave us. And yeah. So we just wrote an equation of a line that passed through that point and was perpendicular to this line. Alright, so that's parallel and perpendicular lines. Remember how to compare their slopes and how to write equations for each one.